Okay, in this video, I'm going to use Solmetric's online tool to determine tilt and orientation factor and go over a little bit about how TOF impacts irradiation levels. So here's an array. It's a 1500 watt array. You can see I'm faced at southeast and my tilt is 19 degrees. If I'm in Philadelphia, Pennsylvania, which has a 40-degree latitude. So my ideal tilt would be around 40 degrees, and obviously I'm in the northern hemisphere here, so I should be 180 degrees south. So I don't have my optimal tilt and azimuth, and what I'm going to determine here is how much this tilt and orientation will compromise my output. And then I'm going to play around with the numbers a little bit just to see what would happen if I put it flat and so forth. So what I'm going to do is I'm going to go to Solmetric. They have this really great online tool. So it's solmetric.com. Okay, and so they sell solar equipment and some other things. But for our purposes, we're going to use it for this insolation lookup tool. So you go to support and then annual insolation US. So you click that. So you really have two options here. One, you can go to the insolation lookup tool, or you can go in Google Earth. So I'm actually going to take the Google Earth option, which is great because now I can search by an address anywhere. I'm bringing that window over here. Okay, so here's Google Earth. Hopefully you're familiar with this. If you're not, it's a free software that you can download from Google. So I'm just going to search Philadelphia, Pennsylvania here in the search bar. Okay, so all of these little sunshine pointers are locations where they have solar data, and so that's what we're really doing. We could just manually go in. I know where Philadelphia is. I could zoom in here, or the kind of fun way to do it is you go to Philadelphia, USA, you click search, it's going to pop up and it'll automatically, now I'm not touching it, it's automatically drawing me in. Okay, so there's where I am, and so what I'm going to do is pick the closest one. I'm in this sort of vicinity. This is North Philadelphia, so I'm going to be down here. So all you have to do is click this sunshine, and then I think you click it again. Yeah, there you go. Okay, so this is my tilt and orientation factor sort of bullseye chart, as I like to call it. I'm going to click. So what you do is if you actually want to enter your tilt and orientation, you click this link. Okay, so now it actually brings this up. So now the two things that I can change on here are my tilt and my orientation. All right, so I'm going to go over this chart quickly. This bullseye tells me my optimal tilt, and then it also tells me if my orientation changes. So here's my azimuth or orientation on the x-axis. So this will tell me the color coding corresponds to this legend over here, which gives me, this is my TOF key. So this is my azimuth and orientation, and this is my tilt. Okay, so the bullseye tells me I'm at 100%, which is a TOF of 1, meaning I'm not losing any of my output. And so you can see with Philadelphia, I'm right, I mean, I can go a little bit off 180 degrees, and my optimal tilt is about 35 here. And it actually tells me up here, optimal tilt is 35, optimal azimuth is 180. So at that tilt and azimuth, my insolation, if you recall, is the energy, the solar energy that hits a surface of 1 square meter over the course of, in this case, a year. Okay, so this is energy, solar energy per year in kilowatt hours. Okay, so that's at my optimal tilt and azimuth. I'm going to get about this much insolation. Okay, now to be clear, this can vary a little bit from year to year depending on how sunny and cloudy and so forth. But this is your average conditions over the course of however they may not, the last 10, 15, 20 years. Okay, so that's my, it actually defaults to my optimal tilt and azimuth. So I'm going to change to my 20-degree tilt, and I had 160 degree azimuth, I believe. So then you just hit calculate. You can see right now I'm at a TOF of 100. So once I click calculate, it tells me my TOF is now 96.5%. Okay, so based on the specs of that array, it's pretty close to optimal. So you can see that this tilt, I'm off by 15, 20 degrees of optimal, but that really doesn't make much of a difference, and I'm 20 degrees to the east of south, so you can see it really doesn't compromise my output that much. It also tells me the annual insolation value at that TOF. Okay, so you can see, remember my optimal here is 1709, and at a TOF of 96.5, it's 1649. Okay, so that's really how you use it, and you can also pick your location here if you want to. But I'm just going to show you if I go flat and it calculated, and if I'm flat, my azimuth doesn't matter because I'm not really faced any direction. And you can see even if I'm flat, I'm only losing about 14% of my output. So flat is not terrible. And then if I do 90 degrees, which is vertical at 180, my optimal tilt, you can see that actually impacts me a lot more. Okay, so I'm over 30% loss at that tilt. Okay, and so that's how you use the Solmetric lookup tool with the Google Earth interface.